Hello everyone, welcome to our second tutorial in practical electronics. Okay, so what is electricity? You could think of electricity, or think of a wire, like a garden hose. Here's our nice little thin garden hose with a little flower at the end of it. And so we have actually three different items in electricity we're going to discuss. We're going to discuss voltage, we're going to discuss resistance, and we're going to discuss amps or milliamps. I know that's an I. It's an I for inductance, or its ability to induce a magnetic field. Even though we don't use it anymore, it should be an A, but people feel that it's been around so long that you can't change it, or you can't do it practically anyways. So this is I for inductance, but think of it as amps or milliamps. Because when we actually do some of our math, and there's going to be some math in this, nothing major, all basic math. We're going to walk through multiple problems, so everybody will be able to get it. V is for voltage, R is resistance, I is amps or milliamps. Okay, now let's take voltage. Voltage you can think of as pressure on our line or our garden hose here. So what happens is we turn on the spigot and water comes out, and of course gravity takes over and forces it to the ground. As we increase the pressure, as we open the spigot more, the pressure increases on the water, and the water actually travels further before reaching the ground. You can think of voltage as this pressure. Now, resistance would be a kink in the hose. Let's say we were to take this hose along some line and we were to put a kink in it. Now that would reduce the flow of water, or reduce the flow of electricity through our line if we put a kink in that. Now what about amps and milliamps? Okay. That you can think of as the size of our hose or the volume of our hose. So we have a thicker hose now. So since we have a thicker hose, more water comes out. But we have the same amount of pressure. Or if we increase the pressure, it's still the same amount of pressure, but our amps and milliamps are the flow. And generally speaking, you have to watch out for voltage when you create your circuit, because that's how you blow things up. Generally speaking, amps and milliamps, the circuit tends to draw what it needs. So if I have a, let's call it a 5, let's call it, if I have an LED that draws 15 milliamps, and I have a power supply, we'll call it a 9-volt power supply, plugged into the wall, and it comes out and it's connected. Now this 9-volt power supply, you're going to know some numbers on here, and we're going to go through these throughout the course as well. It may say, 100 milliamps at 9 volts. Now let's say our circuit with our little LED, and I'll actually draw a little LED here. This is our light. Our light coming off our little LED. Okay, and it draws 15 milliamps. Let's not confuse the one with the light. And, I'm sorry. So we connect our power supply to our circuit, and of course our circuit also has a resistor, because we have to watch out for the voltage. 9 volts is too much for this little LED. They usually like around 3 volts. So we're going to include a 470 ohms resistor. Now you're going to learn all about this. Don't worry if you're not getting all this at once. We're going to review all this in great detail. Okay, so we have our circuit, and of course to complete our circuit we need to go to ground. So we have our positive and then our negative, and we have a complete circuit. We're going to review a complete circuit in a minute. Now this 900 milliamps, this only takes 15 milliamps, But we don't have to worry about blowing up our circuit because this says 100 milliamps. This circuit will only draw what it needs. Of course, if we had a circuit that required more than 100 milliamps, we wouldn't want to use this power supply because this power supply would then get overheat and break down. It actually could burn. I've actually seen them go up in flames. So you don't want to draw more than the rated max milliamps or amps out of a power supply. So let me start anew here. So that's basically, so in this circuit we have our 9 volts. That's our voltage. We have our amps or milliamps. That's right here. This is, you know, how much electricity can actually flow. What is how much can flow through here? And then our resistance is right here. This is our little resistor, our little 470 ohms resistor. And it limits the amount of electricity that gets to here. It takes that 9 volts and reduces it. And you'll see this. We're going to use multimeters and we're going to test these in real life, as well as we'll do the math for all these as well. But anyways, so this is what voltage, resistance, and inductance, or amps or milliamps, is all about. So if you think of it, use the garden hose analogy. And actually, let me add one more thing here, just while we're talking about this. Because resistance resists electricity. It reduces the voltage available to your circuit. But let's talk about a capacitor for a second. We'll draw a capacitor in red. And actually, let's make this an electrolytic capacitor. What does a capacitor do? Well, we know a resistor resists electricity. A capacitor actually stores electricity. And the larger the capacitor, the more electricity it stores. Yes, one leg is longer than the other. This is an electrolytic capacitor, which is, you have to pay attention to the polarization. You know, you have a positive and a negative side, and usually there'll be a little negative symbol here. We'll actually show you pictures of that for the capacitor. So in our first basic circuits, we're actually going to use a resistor, we're going to use an LED, and we're going to use a capacitor. And this is actually the schematic symbol for a resistor. You will actually get to see what a resistor looks like, and basically, in a nutshell, it's this, and it has a couple of different color stripes on it. But we're going to go through all that. I showed you some pictures earlier, and I'll show you some more. So what I want to do right now, though, is discuss a circuit. So let's discuss what a circuit is. Sorry about the bright white. Okay. So a circuit. Let's have a little battery up here. We'll draw a little battery. It's got a little tip here. And that's positive. And this is negative. And we connect our battery to a wire. And on that wire, we have our resistor. And I'm using the pictures right now of what a resistor would look like. Basically from this tutorial forward, towards the end of this tutorial, I'll start using the symbols. You need to get used to the symbols, because when you're reading schematics, they don't always look like this. A resistor, like I said, that you saw from the last one, the schematic symbol can be like this. And we're actually gonna review all the schematic symbols for all these devices. And I haven't decided. I think I'll do a pre-review where we review some of the basic symbols, and then as we add components to our circuits, we will look at what those symbols are. Okay. So now we have our little resistor. And if this was a 3-volt battery, we wouldn't even need a resistor here for our little LED. Then we have our little LED. And a little light coming off of our LED. Of course, there's no light yet because we haven't completed the circuit. And let's bring this down here. And this is going to be a switch called a push button normally open, which means if you're not pressing on it, this circuit is open. A closed circuit is when you touch this. So, and then we bring this back to the negative side. Now, like I said, this is a practical course, and I'm not getting too much into theory. There is one thing I will say. Everybody thinks the flow of electricity goes from positive to negative, and it was a mistake that Benjamin Franklin made that we really can't blame him for, because he didn't know about electrons at the time. And but just so you understand, and when you look at schematics, sometimes they show the flow of electricity going from positive to negative, but it actually flows from negative to positive. We don't need this information really for where we're going with our electronics, but I just thought you should know that. Okay, because this resistor, if I put this resistor down here, this circuit would still work and it would not burn out this LED. It doesn't matter where in the circuit I put this resistor. As long as it's in line with this, you won't burn out your LED. We'll call this a 9-volt battery, and we'll call this a 470 ohms resistor. I'm sorry for that 7. I should actually make these kind of smaller. 470 ohms resistor. When we press this button, the flow of electricity goes backwards, or not backwards, but it goes the way it should go, and the light lights up. This completes our circuit. You need a complete circuit for your circuit to work. And this is as basic a circuit as you can get. We could probably do a 3-volt battery here and eliminate the 470 ohms resistor, which would even, and the switch, which would even be more basic a circuit. Let's actually do that. So here's another little battery coming off here. Now this one is 3 volts. And we have a little LED. Some light coming off there. Hopefully as I do these tutorials my drawing skills get better. And no switch. So basically that's a circuit. We're actually going to be building some of these circuits. But I just wanted to show you that. Now, before we get into building these circuits, what we're going to build them on is a breadboard. But before I even show you guys that and give you the understanding of a breadboard, I want to mention here that, and I don't know if I've mentioned it yet, one of the most important things you want to have for this course is a notebook. You don't need to take notes on this right now. When we start reviewing the symbols, you'll want to take notes. And I'll let you know what to take notes on, actually. But you'll want to take notes. At the end of this video, I will show you I'll add a little clip to it showing you my notebook. It's full. And basically I have my notebook open next to me when I'm doing most of these things, because you can't remember everything. No one can remember everything. And to have to go through these videos to find out exactly what it was that you needed can be tedious. If you have a little notebook where you jot things down, you can quickly review. That said, let's move on to a breadboard. Now here's our circuits. We're actually going to build them on a breadboard. So let's do a half breadboard. Don't save. Okay, so here's our breadboard. Now to understand this breadboard, actually maybe I'll show you the breadboard open first. Let's open. And breadboard large, breadboard inside. Open. Okay, this is inside our breadboard now. This is a cheaper breadboard. You'll notice that all along here, all these holes right here are connected. They're all connected. And that each line along here is connected. See that? It's connected, it's connected, it's connected. But these are not. So along here, this is connected, this is connected, this is connected. This is not connected to this. There are actually spaces in between these. So this is not connected to this. And so this one here, same thing. This rail goes all the way down and connects all those holes together. This is important. When we start building our circuits, we need spaces between certain components. And this breadboard actually helps us prototype our circuits. And it's one of the best inventions in electronics as far as I'm concerned. You don't have to solder everything together. we're actually not going to have our soldering tutorial for quite some time until after we learn all the components and after we breadboard them. There's plenty of tutorials on soldering out there on the internet. I'm sure you can find a few. So now let's go back. Now that you've seen the inside of the breadboard, let's go back to the last picture, the half board. And this is, I showed you an Adafruit. You can buy these. You can buy these almost anywhere. You can see the little metal holes in there. This is where we stick our resistors and our power supplies. Let's say we have a little battery, and the positive side will plug into this rail, and then you can put the negative side here. You can actually put anything you want in any of these holes. You can put the positive side here, but not to confuse you. What I generally do is I will take the negative side of my battery and I'll plug it in over here. Now anything you plug into this rail is now connected to positive, and anything you plug into this rail is now connected to the negative of the battery. So if I was to say take a LED, we'll be using lots of LEDs because it's a good feedback electronic device. So we're going to draw this sideways. This is the LED. Now if I was to take this LED and I was to plug it in here and then plug it in here, now this LED is actually connected to this. This is going to be a 3-volt battery. We're going to keep this simple for right now. So this is a 3-volt battery. So the LED, even though I drew the lines, is not on. It's not currently on because it's not connected to the power. This rail is not connected to this rail. This rail is not even connected to this rail. If I came over here and I plugged, if I went from this rail and I took a wire and I went over to this hole right here, and then I went here over to this here, our light would still not be on. What I need to do is I need to connect power to the same rail that the LED's on. If I connected it to here, and then connected this, and any of these, I could choose any of these holes. I can pick any one of these. These are all connected. And then I plug this into the negative side. Now the LED light would light up. So forget about that line, forget about this line. So this whole rail, so I have power. I could take another LED here, and I take another wire here, and we take another LED, and we plug it into this hole here on one side and this hole here. LEDs have a positive and a negative side, by the way, too, and we'll actually get into that. And then I took this and I plugged it into here, then this LED would light up. So this is how we prototype our circuits. Now let's say we wanted to it's the easiest way to clean this up. Half breadboard. Oh. No, don't save. Open half breadboard. Okay. So now let's say we have a 9-volt battery. This gets a little more complex. So this is 9-volt, and we plug our positive side into the positive rail, and our negative side into the negative rail. And when we get into diodes, we're actually going to add something in here. It's actually going to be protection for our circuit, so that we don't, if we accidentally put something in reverse, we don't blow it up. Okay. So now what I'm going to do is I'm going to come here. I want to apply power here to this rail. Now, from this rail, I'm going to come out here, and it's going to go to a resistor. And then the resistor is going to plug in back here. So follow this path now, here to here. If I plug something into here, it doesn't affect this circuit at all. It's not connected. We're actually going to draw the connected lines to show you in a minute. Okay, so now I take my LED and I plug it in here. And let's bring it up. Let's make our little LED. we're going to use this schematic symbol eventually for LED. And then I plug this side in here. Now these two are not connected, so we're still not getting any light. Now this comes all the way across here. Now what I could do is I could take any one of these holes and I could run it right over to the negative, and then we would light up. Now let's take a look at the paths here. What's connected underneath this breadboard? Well, I already showed you what was connected, but let's do it again. So this is all connected, one line. It's not connected to this. These are connected this way. See this? These are all connected here, and this one is all connected here. And it's not touching these two. I know I came over a little on that. But anyways, it's not touching those two. So all these are connected. See, that's connected. That's connected. All this is connected down here. So this is how our circuit is. So basically we have, if we follow the black, here we connect here, we get power off of this, and then remember that circuit we just drew? Here it comes over here, here's the resistor, it goes up to the LED, and then out of the negative side of the LED, this is the positive side, this is the negative side of the LED. Now it gets to this rail, but now it jumps from this wire here over to the negative, back to the battery. Now remember I said the flow of electricity is backwards. Well, everybody's used to the flow of electricity being talked about in the other direction. So you'll hear me talk about it in either way. Okay, so these are connected. So this is how we livened up our circuit. So if you remember, the simple circuit before was just the battery, which went to a resistor, which went to a little sorry guys, went to a little LED, and then back to the negative on the battery. Just ignore that. And that's the complete circuit. Well, here it is on the breadboard. It comes over here, and now we're going to trace out the circuit in red. So we come off, we're going to follow the flow of electricity. And you'll hear me call the flow of electricity juice on occasion. We turn the juice on. Inside joke. It goes through our resistor, up this side, through the LED, down here. So we see, even though that's connected, it's not, unless we put something in there, it's not part of our circuit. And then we come back up this way, and back up to the negative side of our battery. So there's our completed circuit. Here it is down here, here it is up here with the breadboard. Now, of course, this is a small circuit for such a big breadboard. This is actually half a breadboard. Let me show you the breadboard I use. Breadboard features. Don't save. Here's the breadboard I use. You can hook up 2 powers and a ground. And what you do is you run your wire here, and then you run another wire to whatever rail you want. And like I said before, or hopefully I said before, I put my positive on this side and my negative on this side. It's too easy to accidentally plug something into ground, or plug it, or something you intended for power to plug into ground, or something you intended for ground to plug into the positive side, and fry your circuit. We're going to add circuit protection to our circuits to help prevent that, but I try to keep the positive and the negative, or the plus volts and the ground on opposite sides. Okay guys, here's a look at my notebook. You'll see lots of stuff in here from beginner. We'll just scan through some of these things so you can get some idea. You can pause. But anyways, I'm just letting you know how critical it is to have a notebook, especially when we get into